Have you ever thrown an object straight up in the air and wondered how high did that actually go, or how long was that in the air? Today we are putting numbers to that feeling. We've got an object shot vertically upwards with an initial velocity of 20 meters per second. In today's problem, we are going to see how to find how high this object goes and also how long it spends before it gets to that height. And finally, we are going to see the entire time it will take this object in the air until it returns back to its launch position. Let's look at the solution. So for the first part of this problem, we are to find the maximum height reached by this object. We know from the problem that we gave an object an upward toss. So that means we gave it an upward velocity. So this object here with an upward initial velocity given as V0, and that was 20 meters per second. This object is going to undergo a vertical motion along the y-axis. So we place our coordinate system such that the vertical axis is this way and then the horizontal axis is that way. So since we are dealing with vectors, by convention, anything upwards would be positive, so along the y direction, and downwards is going to be negative along the y direction. Of course, in this motion, we don't have any horizontal motion. In other words, we don't have any motion in the x direction. So with this object thrown vertically upwards, what happens is that it goes straight up, gets to a maximum height, which we call h max. So it started from some origin. Let's call that the 0 point somewhere here. So that is the 0 point. So vertically, it is displaced until it gets to some maximum point, which we call the h max. And since the acceleration of free fall is acting vertically downwards, since the acceleration of free fall vector and the velocity vector are pointing opposite to each other, this object is going to decelerate. That is, it is going to slow down until it reaches this maximum height, where at that point, the velocity of this object becomes 0. So in a nutshell, that is the physics when we throw an object vertically upwards. So with this, we can go back to the kinematics equations of motion, which we know that we have 1 to be delta y, which is the vertical displacement, is equal to 1/2 gt squared plus v0 y, that is the initial vertical velocity. In this case, we call it v0, times time. That is the time or the amount of time it will take this object to travel this displacement. The second equation we can have is the final velocity squared is equal to the initial velocity squared. So v0 squared plus 2g and then delta y. And then finally, we have this equation, which is the final velocity is equal to the initial velocity plus gt, where g is just acceleration of free fall. If you look at this problem, to find the maximum height, we know the initial speed given to this object. We know the initial position of this object. Again, we know the final position of this object, in this case, our h max. So that is our y final. And also, at that point, the physics tells us that the vector of acceleration of free fall is opposing the velocity vector. It slows the object down until that velocity at that maximum height is 0. So that means at that point, which is our v final, is going to be 0. Therefore, the appropriate equation to use to solve this problem is this second equation. And why is that? This is because we know v final, we know v initial, we know g, and also 2 is just a constant. So we can find that displacement or that vertical displacement, which is our vertical height. We choose that equation, v final squared equals v initial squared plus 2g delta y. Now notice something. Delta y, by definition, that is displacement, is change in position, right? So we should remember that this object started from some initial position and then went to some final position. So delta y means we have the final position minus that initial position. So if we plug in these values, we can see that that final position is the maximum height. Therefore, we have h max, and then minus the initial position is our origin, in this case 0. So we have 0, and that results to h max. Now we can simplify this equation to the final velocity squared equals the initial velocity squared plus 2g and then h max. Another interesting thing to note is that acceleration of free fall is pointing downwards, and per our coordinate system, any vector pointing downwards is going to be negative. Therefore, we can have v final squared equals v initial squared minus 2g h max. Now the goal is to find our h max because we know v final squared to be 0. So v final is 0. V initial is given to us as 20 meters per second, and then g is 9.8 meters per second squared. So isolating h max will result in h max equals v naught squared divided by 2g. And in this case, that is just 20 squared divided by 2 times 9.8. And that should give us approximately 20.4 meters. So what this means is that this object, upon being thrown vertically upwards with some initial speed, is going to go 20.4 meters high. If you have any questions, please pause this video and then leave a comment down below. Let's look at the second part of this problem. So to find the time taken to reach the maximum height, we just found that the maximum height this object could reach, h max, is about 20.4 meters. However, how long did it take to get to that maximum height? So to find that is very straightforward. What we can do is that, again, we know the initial speed given to the object to be 20 meters per second. We know g, which is acceleration of free fall, to be 9.8 meters per second squared, and we are to find the time it took this object to get to that maximum height. Now we have two equations left. So the best we can use is v final equals v initial minus gt. And this minus, I explained it previously that acceleration of free fall vector points downwards, so it becomes negative. So with this, we can substitute this t to be our t max. That is the time it took this object to get to the maximum height. We know at the maximum height, the final speed is 0, so vf equals 0. We know the initial speed to be 20 meters per second minus 9.8 times t max. So all we need to do here is to find t max by isolating t max. So generally, t max would just be that initial speed divided by g. So substituting or plugging in our values, we have 20 divided by 9.8 meters per second squared. And that should give us about 2.0 seconds. So it's going to take about 2.0 seconds for this object to reach that maximum height. So that is how to find the time it takes to reach the maximum height. Again, if you have any questions, please pause this video and then leave your comment in the comment section. Finally, which in this part, I'm going to also show you a very interesting trick depending on the kind of problem that you are looking at. Some problems are very symmetric, and for such problems like this one, you should be able to use this trick. But before the trick, I'll take you through how to find the complete time of flight. That is how long it took this object to leave point A, went up to point B, and then back to A. So remember, we calculated the time it took this object to get to the maximum height as t max, all right? And then we found that t max was about 2.0 seconds. So we know that. But how long is it going to take to get to the maximum height? Momentarily stops and then comes back to point A. That is back to the origin. In this case, back to your hands. So this is very interesting because there's a very special trick which I can show you, provided the object only left your hand at this point A, went to point B, and came back to point A. All right. In the instance where upon returning, the object misses your hand and then goes other routes to point C like this, then we cannot use this trick. All right. So let's look at that. So we are left with one final equation, which is the displacement equation. Delta y equals 1/2 gt squared plus v naught, which is our initial speed, times time. All right. Again, g is negative, so I place a negative sign here because the acceleration vector points downwards. This object started at point A, right? So point A, which is the initial position, so we call it yi, and then went up to point B and then back to point A. So what it means is that the y initial equals the y final is 0, meaning the displacement is 0. And this brings us to the concept of distance and displacement. So distance is a scalar quantity, is just the magnitude or how much distance did this object travel. However, for displacement is a vector quantity, so we need to consider both the magnitude and the direction. So if this object travels vertically upwards to h max, that is a positive vector, and then traveling from point B back to A, that is a negative vector because they are opposite in direction and they have the same length, the distance is the same. Therefore, the displacement becomes 0. So the left-hand side here is solved. So what we are left with is 0 equals v naught t minus 1/2 gt squared, or 1/2 gt squared minus v naught t equals 0. So this is a quadratic equation. So we can factorize our time. So t out of the bracket, we can have 1/2 g, another t, so that we can have, if this multiplies that, we have the same term as 1/2 gt squared, and then minus v naught, and that's it, because if we multiply, then we have v naught t, which is just the same as this term, equals 0. So here we can see we have two solutions. So the first solution, t equals 0 at time equals 0. Where is this object? It's at point A. So that is the first solution, and we don't need this at this time because all we need is the time it took this object to go from A to B and then back to A. All right. So the second solution is going to be 1/2 gt minus v naught equals 0. And then we can isolate the time. So time is going to be 2 times v naught over g. And pay attention to this term. We can see that this term is just the time it took this object to get to the maximum height. So because this problem is symmetric, we are assuming no air resistance or air drag acting on this object. Therefore, it will take it the same time to leave point A to B and also the same time to move from point B to A. Therefore, we can simply say that time is equal to 2 times the time it got to the maximum height. And that is the trick. So immediately, if you can identify that this is a very symmetric problem, you can apply that without having to go through this quadratic equation. The time of flight, then it would be 2 times the time taken to reach the maximum height. Awesome. So here we have the time of flight, that's the time for the entire journey of this thrown object, is going to be 2 times the time it took to get to the maximum height, which is 2.0 seconds. Therefore, we have the time is equal to 4.0 seconds. All right. So this brings us to the end of this problem. Like, share, and subscribe if you've not subscribed yet. And also, I'll see you in my next video. Thank you.